Oh, thank you. Thank you for the welcome. And, well, good morning, everyone, high and low. It's great to be here. I know you just had even too much information thrown at you, all these things in so little time. So I'm going to keep it up and be quick as well. And everyone says that they love to be here. I actually mean that. I love the venue. It's more like a techno club than the proper kind of venue you get at these places. I'm based in Berlin. I love techno, so it works for me. So I'm going to keep it fast because we have a lot of ground to cover. But before we dive in, I'm going to give you a little bit of where I'm coming from. Yeah, I mean, when people ask me what I do, I say I'm an orchestrator, which is another word for saying that I work across projects, basically. Everything from inception to implementation to communication, you name it. I've been working with data since the 90s. And to give you an example of the kind of thing I do, my latest project is working with a Swedish NGO, and we're collecting and processing millions of data points with the goal of having transparent supply chains. You hopefully will be hearing about it soon. I have the chance to be involved in many interesting projects over time. One of the most interesting things I've had the chance to do was actually monitor this space. And I've been doing it as an analyst with analyst companies, with my own company. I've been doing that with ZDNet for the last couple of years. And so what I'm going to give you today is, well, what we typically do at the end of the year, which is a top 5 countdown of the most important things that have been going on for the last year. And I hope you will enjoy it. Keep in mind that all I'm going to talk about is online, either publicly or you can find it in reports, you can look me up, it's all there. So, number 5, streaming becomes mainstream. So when most people hear about streaming, they'll think about something like Netflix, for example. Well, you probably know better than that. When we're talking about streaming in the context of data, we're talking basically about real-time data processing. And when people want to do that, traditionally, let's say, most of them have been using something that's called the Lambda architecture, which basically consists of 2 different streams of processing. One of them is processing historical data. And you need to do that because, well, if you only process incoming data, this is great, but you also need to have some context so that you can drive to better conclusions. So this works, but it's very cumbersome. I mean, the problem with that is that you have to maintain 2 different code bases. It's complex. It's hard to scale. I mean, there's a number of issues with that. So people have been trying to squash that, and actually it's kind of working. And what we now have is something called the CAP architecture, which is basically having one line of processing. And what enables that is the fact that, well, we have new technology that helps us do that. The reason this is happening is that, well, because it makes sense. There's lots of application domains. Traditionally, when it comes to streaming, the 2 archetypal examples are Internet of Things and financial services. You probably heard them 1,000 times, but there's actually more coming into play. So we have things like programmatic advertising. If you're here today, you heard about it. There was a very interesting panel on that. We have also applications in retail. So, for example, a very impressive application such is, well, if you are able to process online transactions in real time, this means you get the chance to get back to customers and actually reprocess transactions that would have been otherwise rejected. And so this gives you the chance to reduce abandoned transactions by up to 80%. This is pretty impressive and obviously drives your sales up dramatically. Right, so who does that? I mean, what kind of platform would you use to do that? There's basically 2 different camps here. So on the one hand, we have all these Apache, basically open source projects, such as Spark and Flink and Kafka. Each one of those has its own plus and cons. They do different things. Each one of those has a commercial entity behind them as well. And, well, you can use them on-premise or you can use them in the cloud. And then, on the other hand, you have basically your major cloud providers, Google, Amazon, and Azure. And again, they all have their own benefit, but to me, what's more interesting in this space is that you have something in the middle, which is called Beam. It's a project that was started by Google, and the idea there is to have like a common API and processing framework that will allow you to work across platforms. It's a great idea. It doesn't really work that great in practice. There's a number of reasons for that, but we have to move on. So next, number 4, we have what we call hybrid transactional analytical processing. That's a long name to state a kind of obvious thing. So historically, when working with databases, you have two flavors. One of them is transactional databases. When you have your data store, when you have your data shop, you need to, your web store, you need to basically quickly and reliably process transactions. When you want to derive insights out of the transactions, it's a different story. You're running long-running queries, you are running complex queries, so two different sets of requirements, two different sets of databases to cover those. But the good news is that, well, these two seem to be converging. So it's right, as we said before, in terms of convergence, real-time and historical data, well, now it's actually possible. You're getting to the point where it's actually possible to have what is like the pipe dream of databases, like one database that can do it all, combine analytical and transactional processing under one hood. It's great. Actually, it's very complex, and this is exactly the reason why it hasn't been really done up to now. But we're now seeing solutions emerging in that space. We have a couple of startups that work there with very impressive results. We have Google, the ever-present Google, and you probably heard about Spanner. It's a multi-region cloud database that also does that to some degree, at least. We have even Hadoop providers that are moving, Hadoop vendors that are moving in that space. Next one, if this thing will, yeah. So, number 3, Insight Platforms as a Service. Again, it's a fancy term, and it's basically used to describe something that has been going on for a while. So, if you think about it, the whole reason, the whole idea of having data and analytics on top of them is to get insights. But there's a number of things you need to have in place in order to get to that point. First of all, you need to have your data management in place. So things like storing data, pipelines, and the like. And then you need to have your traditional, let's say, analytics in place. Dashboards, visualization, drill down, you know how it works. But then the actual goal is to have insights. So what happens is that you use this infrastructure, let's say, so that some people sit down and work a lot with the data and get some conclusions out of that. So the idea is that now all these ingredients are being automated and they are offered as a service through the cloud. And the reason this is happening is basically, well, this is a sort of natural progression, evolution, if you will. So applications are moving to the cloud. This means that that data they use are in the cloud as well. The data they generate are also in the cloud. So it doesn't make much sense anymore to move data back and forth between on-premise and your cloud. If most of your applications work in the cloud, then it's perfectly reasonable that your analysis will be done in the cloud as well. And then, this Forrester did this survey. Actually, it was Forrester that came up with this term. And they asked, a number of decision makers in different organizations to give them their #1 priorities. And, as you can see here, all of them are moving to the cloud. All of them want to do analytics. They're going to use machine learning. And actually, machine learning is a key ingredient here in terms of insights. So the idea is that even the work of analysts, the work that people will have to sit down and do, can be somehow prepackaged, automated, and offered as a service in the cloud. So who's doing that? I mean, it's kind of obvious that since we're talking about cloud providers are a prime candidate to offer that service. If you are, I don't know, a Google or Amazon or Azure user, and most of your data already resides there, then it's very tempting to actually go out and use the service that these providers will give you. And there's plus and cons in doing that. I mean, well, the obvious advantage in doing that is that you sort of have like a one-stop shop solution. Everything is there. I mean, you don't have to worry about integrating stuff, and it just works. The obvious downside to that is that, well, you get this vendor lock-in. So if everything is there, that makes it kind of hard to migrate. And obviously, they will try to do everything in their power to keep you there. So that's why, besides the big cloud vendors that are sort of leading, let's say, the space, at least according to analysts, we also have emerging solutions from, again, a couple of startups like Qubole and Databricks that are heavily based on automation. This is their selling point, they say. And we even have Hadoop vendors that are moving in that space as well, progressively. It's in their own way and at their own pace, because it's not really so much about Hadoop anymore, like, I don't know, my distribution is version than yours or whatever. It's about what you can use Hadoop to do. All these data lakes and all those things that you probably know already. So this is where things start becoming really interesting. Up to now, we've seen like the three key points that have been going on. And now we're starting to see the repercussions of this. So we're basically moving up the analytics stack. And what we mean by that, you probably know already this classification of analytics. So the whole idea is that you store your data in order to be able to analyze them afterwards. And you begin by asking very simple questions. What has happened? That's basically called descriptive analytics. Then, using the kind of BI and dashboarding tools that we mentioned earlier, drilling down and correlating will enable you to answer a bit more complicated questions like, why has this happened? So, for example, my sales dropped 20% last month. So why did this happen? Because this department in Nebraska did underperform. So up to now, I think it's quite clear, and this is the kind of thing that everybody more or less has been up to this day. Where things start getting really interesting is when we move to predictive and prescriptive analytics. And this is the part where, again, machine learning and, well, let's mention for the first time the term AI starts coming into play. Because these technologies enable you to go beyond that. So keeping up with the previous example, what will happen, how my sales are going to go in the next month, for example. What's the projection? Are they going to go up? Are they going to go down? And as you probably know, you can use different sort of machine learning algorithms and techniques to make that happen. But when it really takes off is when you get to the last or ultimate step in analytics, which is called prescriptive analytics. So not just what's going to happen to my sales, but what do I need to make my sales go up? That's obviously not just a simple question to answer anymore. It really borders on AI if you think about it. So what do I need to do? It's a very complex question to ask. And well, the reason this is happening now, as again you probably heard like 100 times already, is that, well, because we can. That's the answer. I mean, it's not that the machine learning algorithms are all that new. They have been there for a long time. We have seen developments, yes, but many of the techniques are the same. It's not that the data science has not been there. It also has been there. I mean, we didn't call it data science before, maybe. I mean, but we've always been building pipelines. We've always had databases. We've always had statistics. All of these things that make data science what it is. What's different now is that, well, we now have all that data, and we now have all that compute capacity. So we've reached a sort of tipping point where things just start to work. Things like deep learning that didn't really work anymore because there was not enough compute power, there was not enough data. Well, now they do. So who is doing that? That's a very good question, and it would take a really long day just to answer this question. So I'm not going to go deep into that. There's a ton of machine learning libraries and frameworks are there. You can pick and choose. So these are all in the left column in the slide that you see there. What's interesting, I'm going to focus on two things. So the middle column is there's a number of solutions in something that's called embedded analytics, which is basically about this. So instead of having your application, going to the back end, trying to collect all the data together and do some analytics on them to find out what's going on, now the trend is that you see applications that come pre-packaged with their own embedded analytics. So Salesforce, for example. And what's more, not only do they come with their own built-in analytics, they give you frameworks that you can use to build your own data-driven applications on top of that. And again, Salesforce Einstein is a good example of that. As to who's doing that, that's kind of obvious. I mean, there's a lot of organizations that do that, but I would say that the iconic organizations that do that are, the Facebooks and Googles and YouTubes of the world. They are the ones that have been actually applying the kind of what we just described earlier as prescriptive analytics. So getting you to come back for more, basically. So YouTube, it's, the recommendation engine, for example, it's spookily good. Actually, it gets to the point where it knows what you want to see next before you even do that. And it's very interesting to analyze how it works. So this brings us to the last point, which is what I call machine learning feedback loop, or what others have called the AI lock-in loop, which is a very simple idea if you think about it. So we have these data-driven or AI-driven products. And what happens is that when you do that, it's a sort of scientific way, let's say, of building a product, right? So when you do that, you have a product that performs much, much better than the rest in the market. So you are successful. This brings you profit, this brings you revenue, and by doing that, you have a successful product that keeps operating, it generates more data, you use that data to enhance it even further, you use that profit to recruit talent, to have infrastructure, to do everything that's required to keep building your product. So you get in this sort of feedback loop. And, well, the reason this is happening, again, it's why not? I mean, it's better. It's proven that it's a better way to build a product. It's cheaper. Maybe not initially, it takes some investment, but in the long run, it is cheaper. And it works better. And plus you have the fact that, it takes AI skills to be able to do that. And AI skills are in short supply. So you have to automate as much as possible. And we've even gotten to the point where we have what people have called AI that builds AI. So machine learning frameworks that let you create machine learning algorithms. And so the feedback loop gets stronger and stronger. As to who is doing that, well, that question brings us back to the question that we just answered in the previous slide. So the Googles and Facebook of the world. So, we've heard again 100,000 times probably by now that data is the new oil. And, well, in the future, there will be more data and less oil. So arguably, the most valuable resource is data. And so that's increasingly getting realized. And you have, for example, people even from the economy saying that, well, the data economy needs to be regulated and there has to be antitrust rules. So that brings us to a key question, in my humble opinion. So that's a very important topic that you don't really hear talked about. And the question is, why? Well, maybe she can answer. Her name is Amelia, and she's an AI assistant. You probably don't know her because, well, unlike, I don't know, Siri or Cortana or the rest of them, her target audience is not consumers. So her job is not to order your pizza. Her job is to automate an enterprise. And what that means is that, well, if I'm running a business and, well, I have a customer care service center in all likelihood, right? So what Amelia can do, for example, is she can automate that. And again, you've heard different stories on bots and conversational bots and so on today. And well, what she does is she learns by feeding her data, documents, and by actually monitoring conversation. And she is able to do the task that people in customer call centers do faster and cheaper and drive up customer satisfaction and drive down revenue. And this is kind of awesome, actually. It's great. And not only that, she can also do things like integrate applications. So think about HR, right? I mean, instead of just walking to your HR people and saying, I want some sick leave or whatever, she can do that because she integrates application. Everybody that has worked with enterprise application integration knows that it's a tough job. But it can be automated, as this goes to show. I know it may sound a bit weird, but it's actually true, because, well, 7 out of 10 world's top banks are using Amelia as we speak. And this is all awesome, but there's just one problem. What happens if you're on the side of the people whose job gets automated? So when I was discussing this exact issue recently with actually the CEO of the company that built that, he said to me something interesting. He said, well, you know what? I haven't met a single CEO from Deutsche Bank to JP Morgan that has said to me, yeah, this is going to have great social impact, but so wait and let's think about it. Sorry to let you down, it just doesn't happen. So this brings us to the last point. So what does it mean to be data-driven? To me, at least, it means to be able to ask the right questions, have a proper methodology to be able to answer the questions, and then to actually act on the answers. So to me, this all means that maybe we are being data-driven in the wrong way or in the wrong direction, because we're not really asking the right questions. Thank you.